Hello everybody, this is Dr. Christopher White, and in this video we're going to be looking at the lab exercise stratigraphy. So when a geologist visits an area, they're going to go to every outcrop they possibly can to identify all of the layers of rock which occur within a given area. Now once the layers have been identified, a geologist will then move to classify those layers. If the layers are sedimentary, they will then try and work out the environment of deposition for each of those layers. And then, of course, they're going to try and put those layers into a chronologic sequence using relative or numerical dating. Now, once they've put the layers of rock into a chronologic sequence, of course, that then allows them to work out where the package of rocks sits relative to other rocks in a given area. And it also allows the geologist to put the package of rocks in the context of the geologic timescale. So they'll be able to give it a date. For instance, this package is Devonian or Permian, etc. Now, the processes that they use to do this are the basis of stratigraphy. And so we're going to be looking at some of these techniques in this lab. Now, once a geologist has visited the exposed rocks in an area, they are going to put those rocks into that chronologic sequence. And this will result in the production of a stratigraphic column, and we can see an example of that over here on the right. Now, the column is going to display several features. So the first feature is, of course, the rocks are going to be in chronologic order, with the oldest rocks at the bottom and the youngest rocks at the top. It is also going to display the rock types and any sedimentary structures. So as you can see from this example stratigraphic column here, the rock types are defined by different colors and different patterns. There will also be distinct symbols which are used to denote certain sedimentary structures. So as you can see, this sandstone layer here has this distinct kind of scallop shape to it, these scallop lines, and this is denoting cross bedding. You can also have other symbols for things like ripple marks or for mud cracks or root casts, etc. You will also see the thickness of the layers displayed in your stratigraphic column, and the thickness can either be relative, so there will be no scale bar on the left-hand side of your stratigraphic column, or it can actually be measured, in which case there will be a scale bar on the right-hand side of your stratigraphic column. The column will also show you the type of contacts which are occurring between each of the layers of rock. So it will tell you, is it a sharp contact, is it a gradational contact, or is it some kind of erosional surface, so an unconformity. So if we look at our example cross-section right here, you can see that some of the layers are separated by a clear, sharp, black line. That's going to be a sharp contact. So there's a distinct change from one layer of rock to another. Then you have erosional surfaces, so unconformities. They will often be displayed as an undulating contact between layers. And then you have gradational contacts. So gradational contacts can be displayed in a number of ways, but in this case I've chosen to display it as a dash line separating layers of rock. The final thing that you're going to see on your stratigraphic column will be the resistance to erosion for each layer of rock. And so as you can see in this particular stratigraphic column, you can see that the most hard-wearing layers of rock are going to be the sandstone because they stand furthest out. Then that's followed by the limestone, and finally the most easily eroded layers of rock are going to be the mudstones in grey. So you can see that the stratigraphic column is giving a lot of information about the geologic relationships and some of the identifying features of the layers of rock for a given area. Now, following the production of this stratigraphic column, the geologist is then going to aim to put the package of rocks within the geologic timescale, and in order to do that, we are going to primarily use fossils if they are sedimentary rocks, or radiometric dating if it is a package of igneous rocks. Now, once the geologist has done this, they are then going to try and also interpret what's happened to the sequence after the rocks formed, so after they were lithified. Has the sequence been tilted or deformed in some way? All of that has to be accounted for. So when we think about analysing a stratigraphic column, the most common method that you would envisage is by splitting that stratigraphic column into distinct layers, which we term, of course, as beds. Now, the differences between these beds are based on the changes in the lithology, and of course, each lithology is going to have a different mineralogy and therefore a different appearance. So, for instance, between different beds of rock, we're going to see differences in color, maybe. We're going to see differences in composition, so what minerals are present, which obviously then will affect the color. And we're going to see differences in texture as well, especially for sedimentary rocks. Are there different sedimentary structures associated with each of these layers? Now, this is the traditional way of thinking about splitting up a stratigraphic column. However, it's not the only way that this can be achieved. So we can also split up a stratigraphic column into distinct portions using things like fossils. So we can say, right, fossil A makes its first appearance here, fossil A makes its last appearance here. I'm therefore going to use fossil A to define a range zone. You can also do it based on age. If you have sufficient geochronological data, so you have numerical ages for certain points in the stratigraphic column, you can say, fine, I am going to make a unit which runs from 400 million years to 402 million years, maybe. And that will be your distinct portion of that stratigraphic column. You can also do it based on rock chemistry. Now, this would be more commonly used in systems which are igneous. So you would split it up based on, right, this lava has this composition, this lava has this composition, etc. But it can also be applied to sedimentary rocks as well. And the final way you can do it is via paleomagnetism. And of course, as we've discussed, this is due to the orientation of iron oxide minerals within the rock as it is either deposited in the case of sedimentary rocks or during the crystallization process for igneous and metamorphic rocks. And so what we can do is we can take the sequence of paleomagnetic changes that we see for the stratigraphic column, so when you have a normal or reversed magnetic field, and then we can apply that and we can see, right, where does this fit within the geologic column based on this paleomagnetism? And then we can split it up into distinct units based on certain paleomagnetic events. So you can see there are a few ways in which we can actually split up our stratigraphic column, and obviously you'll have to pick whichever is the best solution for the area which you are dealing with. Now, when it comes down to it, there are three main ways in which a stratigraphic column will be divided. The first one is lithostratigraphy, and this is simply based on the rock types. So you'll use the differences between the layers or the differences between groups of layers in order to allow you to split them up into distinct units. The next option is biostratigraphy, and this will use fossil assemblage. So once again, just like I previously mentioned, you would use the first appearance of a fossil and the last appearance of a fossil, or maybe you'll use the first appearance of fossil A and then the first appearance of fossil B to define your range zone. And the final method is chronostratigraphy, and this one uses the ages of a sequence of rocks, and it's primarily based on either geochronology, so you have a numerical value, or fossils for which you have a definitive age, which you can also use to provide a numerical value for a portion of your stratigraphic column. You can also use relative dating to do it in very certain circumstances, but most of the time chronostrat is going to be based on geochronology using either radiometric dating or geochronology using the presence of a fossil with a known age. Okay, so once we have our stratigraphic column, and obviously it's in chronologic order, we are then going to divide it up into distinct units. So if we are using lithostratigraphy as our method, we're splitting it up based on the units of rock, we are going to call these distinct units formations. If we're dealing with biostratigraphy, so we're using fossils to split up our stratigraphic column, we are going to refer to them as biozones. And if we are using chronostratigraphy to split up our stratigraphic column, we are going to split it up into units referred to as systems. Now, separating strata into units obviously makes the stratigraphy easier to describe, it makes it easier to quantify, classify, and also to interpret. Now, this also helps to reduce the total amount of information that you need to actually, use. So when you think about it, if you think of a standard sedimentary sequence, it's not uncommon to find multiple thin layers, one after another. And if you were to go about analyzing each of these layers and considering them a separate unit in their own right, you would obviously end up collecting an astronomical amount of data, because you'd have to collect the same data for each one of these thin, let's say 1 centimeter thick layers. So you would have a lot of information to deal with. However, if you were to say, okay, what I'm going to do is I'm going to take all of these thin layers, because they probably formed in the same type of environment, and I'm going to put them all together as a formation, it's going to make your life a lot easier, because then you're just analyzing how did this formation form rather than how did each of these individual layers form. So splitting up your stratigraphic column using these methods really helps you to analyze it without producing excess data in the as part of that process. Okay, so let's move on to part 1. So we're going to begin by looking at lithostratigraphy. So lithostratigraphy uses the relationships between beds in a stratigraphic column to divide it into smaller units. So one of the methods that's used to divide the column focuses on the contacts between these beds of rock. So as we've discussed in lithostratigraphy, because you're dealing with different layers of rock, they are going to have different appearances, and as such you can relatively easily split them up into distinct layers. So if we look back at our stratigraphic column here, we can see a limestone is obviously going to have a different appearance to a sandstone, and a sandstone is going to have a different appearance to a mudstone, and a mudstone is going to have a different appearance to a conglomerate. So you can visually quite quickly split up your stratigraphic column into distinct units. Now, if we are using layering, so these different layers of rock to split up our stratigraphic column, what we need is obviously we need for each of these units to have a defined upper and lower boundary, because you need to have a sharp transition from one unit to another. So this means that when we are splitting up our stratigraphic column, we need to focus on sharp contacts. So this means either a regular sharp contact or an unconformity. So if we come down here to this figure, you can see here's our stratigraphic column again. And you will notice that when we look at the stratigraphic column, I'm actually just going to zoom in a little bit just to make things a little clearer. Here we go. You can see that where we have a layer that has a sharp contact, it's obviously marked by this clear black line, single solid black line. Where we have an unconformity, it's marked by this undulating line. Now, these are sharp contacts. You will get a nice clear distinction between the layers at that contact. So the next question is, what happens if you have a gradational contact? So if you remember, a gradational contact is simply where you have a transition from one layer of rock to another. So let's say you have a mudstone, you steadily see an increase in sand quantity, sand content, and then eventually it transitions into a sandstone, and then maybe that sandstone will steadily become more mud rich as it moves up, and then eventually transitions into a mudstone. So in those situations, of course, you are not going to have a nice sharp contact. All you're going to have is this gradation from one bed to another. So the obvious question is, can you use that? The answer is no, because that is not a sharp contact. There's no clear definition about where one unit of rock ends and another unit of rock begins. Now, once we have split up our stratigraphic column into distinct units of rock using sharp contacts, we then need to give each of these units its own name. Now, the first part of the name will be arbitrary. So it can be something like maybe the color of the rock, or maybe it can be named after a nearby town or some kind of local feature, a historic figure, a famous geologist, or even the surname of the geologist that's actually doing the identification of that particular unit. So the first part of the name is going to be arbitrary. Now, the second part of the name is actually going to give you some information about that particular unit. So if we look back at our stratigraphic column here, we can see that this limestone unit has a clearly defined lower boundary and a clearly defined upper boundary. So we have sharp contacts at its lower boundary and upper boundary. So we can use those to define a distinct unit. So if you'll notice, the first part of the name is arbitrary. You can put it in, you can come up with any name you want. The second part of the name in this instance, though, is the rock name. What type of rock is it? And that's because this particular unit consists of only one rock type. You can see the same thing repeated with this sandstone layer here, sharp lower, sharp upper contact, so we can define it as one unit. So it's the insert first name, sandstone. Same goes for this shale layer here, sharp lower contact. In this case, the upper contact is nonconformity, but it's still a sharp contact, so we can use it. This is the insert name, shale, because it only consists of one rock type. So what do we call it if it consists of more than one rock type? So if we look further up in our stratigraphic column, we can see that we have a unit that starts here at the base of this cross-bedded sandstone. So we can see we have a sharp contact right there. However, when we move up, we can see that the contact between this sandstone and this mudstone is gradational. And you can see that we then have several gradational contacts as we move through this sequence of thinly bedded mudstones and sandstones. So nowhere in here can we define a sharp boundary. So we can't actually define a sharp boundary until we make it to the contact between this layer of sandstone and the layer of limestone above. So that would mean this unit would begin here on this lower contact, and it would end here on this upper contact. Now this would obviously mean that we would have more than one rock type in our unit, because we would have both sandstone and mudstone. So in this case, we are going to refer to this unit as a formation. So it's going to be the, whatever name you come up with, formation. So when it comes to labeling your rocks and naming them, it's relatively straightforward. If it's just one rock type, which is part of your unit, you are simply going to name the unit after that rock type. If it's more than one rock type in your unit, it's going to be classified as a formation. Now, some of you have already probably noticed that splitting up a stratigraphic column based exclusively on the position of sharp contacts may not be the best idea in all circumstances. So if you are dealing with big, thick, distinct units of rock, then great. It's perfectly reasonable to split them up based on sharp upper and lower boundaries. However, when you have a situation where your unit consists of multiple thin layers of rock, things get a little bit more complicated. So if we look at our stratigraphic column here, we can see that this portion of it right here has several units of mudstone and sandstone. Now in this case, they have gradational contact, so we can't use the contact in between them to define a unit. However, let's imagine they had sharp contacts. Well, in that case, you would have a situation where you would have to split up this entire sequence into individual units based on the sharp contacts between the mudstones and the sandstones. And, let's say each of these layers is 1 centimeter thick. That's obviously going to produce a huge number of names. So it doesn't really make a whole lot of sense. So in that situation, what you're going to do is you are going to say, right, these mudstone layers and sandstone layers, did they form in the same type of environment? So let's just say something like a delta. So let's say they're part of a delta sequence. Well, then what you'll do is you'll say, even though they have sharp contacts, what I'm going to do is I'm going to define the unit based on the origin of the layers of rock within it. So I'm going to say all of these mudstones and all of these sandstone layers represent a delta sequence. And so I'm going to put them all together as one formation, even though they have sharp contacts in between them. And so it's not uncommon, in order to allow geologists to simplify very complicated stratigraphic columns where you have lots of layers of rock, for geologists to split it up, not based on the sharp contacts, but on the origin of distinct packages of rock within that stratigraphic column. So you'll have one package, let's say, for beach deposits. You might have then one package above that, which is for lagoonal deposits, and then another package of rocks which are related to fluvial systems, maybe. And so that will then allow geologists to split up this very complicated stratigraphic column into more straightforward units based exclusively on the origin. Of course, the one caveat to that is each of these units, which are based on the origin of the rocks, must have a sharp lower and upper boundary. They cannot end on a gradational boundary. It has to be a sharp contact. Okay. So in this particular lab, though, we are going to be using a stratigraphic column that we will be splitting up based exclusively on the contacts. Are they sharp or are they gradational? So if we come down, you will see that we have just two questions for part one, question 1 and question 2. And over here on the right, I'm going to drop down to the stratigraphic column, and I'm just going to zoom out a little bit. Okay, so here is our stratigraphic column for part 1, and you can see it consists of 4 rock types. Obviously, we have sandstones marked in light yellow, we have limestones in a light blue, part of our sequence of rocks. So for question 1, you are going to take this stratigraphic column and you are going to subdivide it based on the contacts. So you can see a couple of examples have already been provided for you at the bottom here. You can see we have a sandstone layer that presents a sharp lower and upper contact, so that's going to be defined as 1 unit. We also have a a limestone layer, which has a sharp lower contact and a sharp upper contact, which you are then going to classify as its own distinct unit. So once you've done that, so once you've split up the stratigraphic column into distinct units, you obviously then have to name them. Obviously, if you remember, the naming convention is you will put whatever you want for the first part of the name, and then the second part of the name has to reflect what that particular unit consists of. So if it's just a single rock type, it will be named after that particular rock type. So this sandstone layer here, I've named the Austin sandstone. The limestone layer above it just consists of 1 rock type, so it's the Dallas limestone. In the event you obviously have a unit that consists of multiple rock types, that is going to be the insert name here formation. So as you can see, part 1 is relatively straightforward. Just split up the stratigraphic column based on the contacts, and then please assign each of the units that you come up with a distinct name. Please do not use the same name again. So for instance, this is the Austin sandstone here, and then let's say this sandstone here is defined by you as another unit. Do not call both of these units the Austin sandstone. You can only use the name once. So this one instead might be something like the Odessa sandstone, for instance. So please don't make that mistake. Now, another thing I will point out is that if you are zoomed out on the stratigraphic column, it can sometimes be a little bit hard to see which boundaries are sharp and which boundaries are gradational, especially when you're dealing with things like the mudstone here, where the mudstone symbol already has lots of thin lines associated with it. So it's always a good idea to zoom in on the image to make sure exactly what type of boundary you are dealing with before you decide to define a particular unit. Okay, so thank you for watching part 1, and please get up, have a walk around, go and get a glass of water, and then come back for part 2.